Kids love toys. They hold it in their hands. It's real, has a purpose. They give it life in their imagination. And you can see how physical computing taps on that. In many of our activities, we build something that looks like a toy, maybe a little pet. Then we use code and we use maybe the lights that we have on the microcontroller to give life to that real pet. So for example, if you wiggle it, then your virtual cat starts to meow, right? Or it starts to show a happy face. So it is, in a sense, very real for the children.
You're listening to the Microsoft Research Podcast, a show that brings you closer to the cutting edge of technology research and the scientists behind it. I'm your host, Gretchen Huizinga. If you've ever wondered if you could find the perfect combination of computer scientists and MacGyver, look no further than Dr. Peli de Halleux, Principal Research Software Design Engineer at Microsoft Research. A key member of the MSR RiSE, or Research in Software Engineering Group, Peli is part of the MakeCode initiative that brings physical computing to classrooms around the country and around the world. Today, Peli talks about the maker movement in K-12 education, the hard work that goes on behind the scenes to deliver a seamless user experience for both kids and teachers, and how to get children excited about coding through hands-on experience in early computer science education. That and much more on this episode of the Microsoft Research Podcast. So you and I share a difficult to pronounce last name.
Yeah.
How do you say your name?
My last name is De Halleux.
De Halleux.
Yeah. De Halleux, yeah, that nasal sound. Pretty
I like
hard.
it.
I've received every possible pronunciation back.
Yeah, and spelling, I bet. Listen, several of the researchers we've had on this podcast have talked about an aha moment in their own lives where they said, hey, that's what I want to do with the rest of my life. Did you have one? And if you did, what was it?
Well, I'm from the 8-bit computer generation. So I had a Commodore computer and played a lot of games on it. I had to type them. So my first programming experience was just writing a loop there. I think it was saying something like poop in the loop. But surprisingly, in
now
high
there's
school,
an emoji.
I learned WordPerfect and I learned how to automate, this whole, you could put names in things and print 500 times on the same page. And I really like the fact that automate stuff. So as programming is really a Word document. And I really dig that. But I really got seriously into coding in college. Before that, it was mostly small-time hacking of games.
And so from there to Microsoft Research, what was your path?
I did a PhD in applied math in previous life. And then I got in contact with people in Microsoft, and I got a job as a tester in the .NET runtime. I was 2 years a tester for the just-in-time compiler. So that's the thing that takes .NET bytecode and turns to assembly. And then, from meeting other people, I got sucked into working on a testing tool called PEX in RiSE. PEX was a white box test generation tool that uses something really cool called dynamic symbolic execution, and it is still available for Visual Studio. And then finally, my colleague said, it's hard to demo these things. Let's put a web front end to it. And my colleague, Nikolai Tillman, is the one who started the project. So we did that, and then a collaborator, Tao Xie, said, you should make it a game. Like, people have to figure out the code. They don't have to test it. So we did that too. And then surprisingly, people like the game.
Yeah.
They played the game a lot. Some people like puzzles. This is the ultimate puzzle. You have to reverse engineer a programming function that might be very complicated. And that's how I think from one step to the other, we ended up in education.
So you're in RiSE, Research in Software Engineering at Microsoft Research. What kind of research do you do?
Currently, I'm working on building code editors for beginners, for kids, around physical computing. So around teaching computer science, around building things and programming physical stuff. But RiSE does a lot of things. I'm just one aspect of the group.
Much of your recent work is in what you call the maker space.
The maker space,
What do you
yes.
mean by that? It's
kind of a buzzword right now. The maker movement, it is a movement, and there's things called Maker Faire and Make Magazine. It's allowing people to build things. You can build it and kind of celebrating making things. And using any kind of technology, whether it's old things like forgery or cutting wood, or mixing new technologies, mixing 3D printing and art and painting. I think the maker movement doesn't really care about how you build things. There is certainly a trend where, because microcontrollers are easier to program, there's more of these kind of technology that is being accessible to non-professional developers, right? And that's one of the aspects of the maker movement.
So how is Microsoft Research involved in that movement?
The physical computing kind of taps straight into the maker movement. We enable it. We enable it because we lower the barrier of entry in terms of programming, making things that leverage microcontrollers and coding. So you don't need to learn an advanced language like, C++. You can use drag and drop programming just like you do in the hour of code, for example.
Well, talk about physical computing for a minute. What do you know about it? What do you do with it? How do you...
Right. It's a mouthful of physical computing. What is it? We use small microcontrollers, so little computers, think about the size of a watch, that you can program, and we allow the kids to use code to build things. So these little computers have sensors that can detect maybe movements or lights or sound, and they have outputs. So they have like lights, or they can do sound, or they can start actuating motors. But you build actual physical things because it's a real, tangible, something you can touch. So that's why it's called physical computing.
Okay, so you told me it was important for kids to interact with a physical object in addition to or before they code it, to animate it or give it life.
Right. So that's the master plan. Kids love toys. They hold it in their hands. It's real, has a purpose. They give it life in their imagination. And you can see how physical computing taps on that. In many of our activities, we build something that looks like a toy, maybe a little pet out of cardboard. Then we use code, and we use maybe the lights that we have on the microcontroller to give life to that real pet. So for example, if we wiggle it, then your virtual cat starts to meow, right? Or it starts to show a happy face. So it is, in a sense, very real for the children.
That's awesome. So on your shelves in your lab, I saw electric guitars, I saw light-sensitive robots, monsters even. I saw soil sensors. These are all things that happened in a classroom. Talk about your experiences that are happening with physical computing in the classroom.
So what we're seeing with physical computing is that it's easy to build projects that are meaningful for students. They are real projects. The range of projects you can address by building physical things is very large because it is reality. The example I like to mention is medical devices, where students want to help their grandparents who, detect when they fall is a classic one. That's the kind of stuff you can build with microcontrollers. The kids who like sports, you can do sports-oriented things. The kids who like fashion, you can do lights. There's a wide range of interests that we know kids have that we can address. The other thing that's really interesting with physical computing is the infinite level of customization can apply to them. And it's very important for students to own what they're building, to feel like that's theirs. And if you're following too many instructions, you have the same thing as your neighbor on the left and the right. It doesn't feel like you've learned or built anything.
Yeah.
If you build a cardboard robot and you decide it's a dragon and your neighbor it's a cat and the other one it's a pizza, you've kind of got your interests. You're in full learning mode.
Yeah.
When it gets to the coding part.
So what I'm hearing is this domain-led, which is a more technical way of saying making it your own. But you find the interest level of the maker, the kid, the developer, whatever, and then you bring in the computing and the coding and so on.
We make it so that the computing is friction-free, so it's not a pain to be brought in. And in a sense, it's seamless. And you want to bring it in. Anytime you're going to add friction to something, people are going to say, it's too complicated. I won't do it next time, and so forth. Giving life to these microcontrollers and these robots has to be so seamless that any teacher is going to say, I'm going to take a chance and do it, although I'm not an expert here.
So talk about the technology that goes on behind that so that it comes into the situation seamlessly.
So at the hardware level, we have these new boards that are full of sensors. So that's the hardware part. At the software side, we need software that is adapted to today's 21st century classroom. So we have browser-based code editors. These are completely cross-platform. They will work in diverse environments. Schools may have deployments of Windows machines and maybe some iPads and Chromebooks and whatever came in the middle. So it's very diverse. So we do all cross-platform. We work offline in case your Wi-Fi is really not good. And also we have developed bootloaders and new file system to be able to flash a device via drag and drop. And that starts the reflashing process. So these boards only run one program. They run the latest program you flash it on. And this kind of unlocks the K-12 world.
That leads into a really good question about physical computing for everyone.
Yeah, it's been going on for a while on Microsoft Research. The first project I know of was Gadgeteer by Steve Hodges, and they had a module system, and they had a coding experience in C# and Visual Studio. And then we got the opportunity to work with the BBC to help deliver the MicroBit. And we tweaked TouchDev to support the MicroBit, but we also built an editor based on Blockly. So the typical drag and drop blocks you would use when you're using the RF code or Scratch, they feel the same way. So there's been quite a bit of activities in MSR around physical computing for a good while.
What are you guys doing here in terms of broad thinking on inspiring creativity in computer science?
With physical computing and in most of our resources in MakeCode, we first make something. And we make something because that thing is going to be, in a sense, custom for every kid. When we do a virtual toy or a pet or an instrument, there is a high level of customization. Duct tape, pencils, whatever they have in their hands.
MacGyvering it.
Right. I mean, kids are really good at crafting. They love that. That means they own the device. The device has a life on its own, on their eyes. It has a personality. And then it's much more meaningful for them to start working on programming it. So that's, in a sense, what you get for free when you're building physical things is that there's this whole crafting thing that people typically love to do.
Back to the maker.
Back to the maker, yes.
Yeah, that does seem like a good approach, is to get kids making things and then seeing what the possibilities are with computer science.
So in the making, what's interesting is, we call it physical computing, and certainly coding is a big aspect of that. But what you quickly discover is that in the making kind of ecosystem, there's, some kids are really interested in coding. Some of them are really designers. They love to design the hardware. They're not so much interested about the rest. Or they like to design the experience, but they don't really like to implement it. Or they like that it looks good. Like the colors are going to be very important. And, it may show them that there is a space for them as a designer and as, a graphic artist in the technology stack, where it's not just code monkeys. It's not just developers. We need designers. We need, great graphic artists, user experience designers and things like that. And building real things, and you build them in a team as well. Working as a team is inherent. When you need four hands to do something, you're going to work as a team.
Right. That reminds me that we discussed the wide range of interests and occupations where you could find a place in high tech. And you mentioned sports, medicine, fashion, games, toys, hardware, all in the context of software engineering. So talk about where you could bring in these other interests and still find a place in high tech.
Let's say I want to pique the interest of some students and I know they're high into sports. Then I'll make a lesson around using an accelerometer sensor to detect, let's say, how many steps they've done, or, how many G's they took when they took this sack in football, or, how many times you can juggle with the ball before the ball falls, for example. But you tap into their passion is sports. If you're a natural born medic, you love to help people. And we see that in many students when we do a test. You probably want to build a medical device. And a medical device that we had a girl who tracked the water intake per day, because some people forget to drink. So they need to be reminded to drink a few times a day. But that was directly, like, her instinct was to build a device that would help other people. Some kids love games, so they're going to build games. There's always those ones. And then some students, music, sounds was great. So, because technology is going into every aspect of life today, we can use that to really excite kids about it by just tapping into their interest.
Talk a little bit about the beginnings of Touch Develop. How did that come about as an idea?
Nikolai Tillman, which was also in the RiSE group, he got a phone like everybody else when the iPhone came out. And after 2 weeks, he rushed into the manager's office because he had downloaded all the apps and he was bored and said, we need to be able to program this thing. And we're all a generation that learned to code on Commodores and 8-bit computers. And we need to bring back the joy of programming of 8-bit computers to phones. And I think everybody turned their head and said oh yeah, that's a great idea. We should totally be able to do that since the hardware specs are much better than what we had back in those days. In our case with Touch Develop, we were we want to be able to code on a phone, for example, and the experience has to be good, even if you're just holding it with one hand and using one finger. So the better experience was, writing text the way you've been writing text on something that's designed to have a keyboard with 102 keys is not going to work when you don't have keys and you just have a touchscreen. So you're not really leveraging the new specificities of the modern phone hardware.
So that just actually sounds exciting. That
it was an exciting time.
Well, so talk about how Touch Develop played out then after the idea came. It got pitched here in Microsoft Research, and everyone said, hey, great idea, let's go. What happened?
So we grew, and then we used it to develop new ideas around distributed computing, maybe interfaces on the code. We do publish these results as we go. We were an early, adopter doing the hour of code. We did the hour of code when it came out.
With code.org?
With code.org. So we explored how far you could go with a phone-only experience. Then we expanded to all computers. So there were interesting questions like programming on multiple devices at the same time. So handling, what happens when you program on these devices that are on and off in the school setting. How do you handle multiple screen size and a unified coding experience around that? Ultimately, Touch Develop got us into the physical computing. So we had done some experiment with Lego and XT, but then we started working on the BBC MicroBit.
Talk a little bit about the MicroBit for a second, because that device is packed.
Right. The MicroBit was piloted by the BBC. They have a research department too, and they went through 4 or 5 prototypes, I think. And so they prototype hardware. They discovered that a screen was very important and buttons were cool and things like that. So they did user research. What's the best age to kind of introduce this kind of tech and things like that. And then when they wanted to go big, because the plan was to give a MicroBit to every student in the UK, every year 7 students, so every 11-year-old. So at that point, they did a call for partners, and then anybody who wanted to help could join the party.
Talk to me about MakeCode a little more. That's the big thing that's happening right now in the school setting. How did that evolve out of other things that you were doing in research, and what's it doing now?
MakeCode is a direct evolution of Touch Develop, then Touch Develop for MicroBit. We did a full rewrite, and then we started working with developer division here, which is the same division that does Visual Studio. We got a team of engineers and started making it a real product. We are all open source on GitHub, and we started working with companies to help them bring their microcontrollers to the market. So we're working with the foundation, of course.
The MicroBit Foundation.
Yes, but we also work with Adafruit and others.
And so what do you do with the schools now with MakeCode?
So a school today with MakeCode can do Minecraft programming, and they can do the Adafruit Circle Playground. They can do the Chibitronics Chibi Chip. They can also do the C, the Grove Zero board. And there's a few others in the pipeline, but those are the ones that are current.
Is your group typically present, or is this like log on and go to the teachers?
Yeah, mostly it's log on and go. We do some user testing where we follow a class for a week.
Mm-hmm.
So we have regular user testing around that. Otherwise, it is used worldwide. We see the tweets coming back from the teachers when they publish their MicroPets. MicroPets is our first lesson on the MicroBit course.
Yeah.
And typically teachers are really impressed by what the kids come up. So we see some pictures popping up on Twitter.
Your audience has been professional developers, and that you've now moved into the end users who are not programmers and beginning programmers, often in school situations. It seems like there's a push to evangelize the programming world.
This shift happened really when we started doing touch develop. So traditionally, Microsoft would sell Visual Studio, or not, they have Visual Studio Code, which are pro grade IDEs. So even if you understand what IDE means, you're a pro. So they are professional code editors, and they are for an audience of professional developers, and or at least some people who are serious about coding. When we started doing touch develop, we basically ended up being an app, and apps are downloaded by regular consumers who may have zero experience around coding. So obviously, children have phones, so they would be at least teens have phone. We like an interesting audience to appeal to. And so that's really how, by saying we're going to program on the phone, we're also saying, we're going to actually address a new audience, an audience that has never coded, because an audience that already codes, let's say on a keyboard, they're typically going to see that and say, this doesn't make sense. They have a paradigm. Now, if you come to the ones who have never known anything else than a phone, it's very natural. What is this thing with a keyboard?
How much hand-holding has to happen in these new environments where if someone downloads an app, it's like, well, I would say, how do I use that?
Yeah, so content is key. There's a lot of content, and there's a lot of work around intelligent tutorials. And I think we don't know precisely, what's the best. And probably there's no students that are the same, so things are going to work sometimes or not. We do also a lot of work to please the teachers. We do work to provide curriculum that are standards aligned that teachers can use to deliver the class. That's very important.
So that comes out of your group as well?
We work with educators to design material that a teacher would like to read, which is not what you want to read. They have their own lingo.
Language.
So we build material for teachers so that a teacher can adopt this and say, okay, I will reach all the standards I have to teach, and I can do that, and this is exactly what I'm looking for. Then we also build material for the random user that's going to use the app, the random kid. So small projects, maybe some guided tutorials where we tell them precisely how to drag the blocks here and there. Our latest editors have kind of like a gallery setting where you'd go shopping for. If you go to our Minecraft editor, for example, you'll see we have, I think, 40 projects that are completely crazy, and they have like shiny screenshots, and then, I want to do a bat cave. Okay, I'll learn about the bat cave, or I want to do like Super Digger. So we tease the interest of the children by doing some really cool mods, typically very small, at least to get started. So we seed the environment with a lot of people will learn just by looking at an example, then remixing it. So we see the environment with that. We also have tutorials that are guided, where it's a very precise route. These are usually the first ones to teach you how the editor works, like how you drag things and which button to press when you're ready. In Touch Develop, we had something super advanced around that. This is still a very, very active area of research that can grow.
Yeah, so there's all kinds of places to go from here.
It's a very interesting space that has massive potential. How can you maximize, let's say people want to learn something online. How do you build a system that really maximizes learning for all the users? If you want to be successful, and if you want to truly have a platform that helps people learn, otherwise you will drop your students. They will not come back because they feel like they're losing their time. You're fighting against all the distractions that are available on the internet. So it's a tall order to keep your audience.
Well, that's the world your
interested.
research is living in right now, is the distraction world.
Yeah, you have to be interesting. Otherwise, they will just go to the other tab and go back to their, best favorite activities of the day.
Well, it seems like what you're doing is really interesting.
You're very true. We're very true to be very interesting and have people learn and, maybe change some lives along the way. Yeah.
Changing lives is good. To learn more about Dr. Peli de Halleux's work with MakeCode and other innovative things Microsoft Research is bringing to your kids' classroom, visit Microsoft.com/research.